Anyway, hey,
All
Stu,
right,
thank
cool.
you so much for doing this.
Yeah,
It's
no
been a
problem.
couple of years since I talked to you last, and just just so people know, because you're one of the top protein guys, muscle research guys, basically on the planet. So you're a great person to ask a lot of stuff about, and I want to kind of pick your brain a little bit. Some of the stuff we've kind of gone over it. Maybe we'll just kind of go briefly through that just to kind of reinforce the message, because we seem to have to continue to do this. But let people know, what do you do, Stu? What's your background?
Sure, yeah. So I'm a professor in the Department of Kinesiology at McMaster University. Our research centers around, if we put an organ right in the middle, it's skeletal muscle. We kind of divide it in. One side, it's older people. On the other side, it's younger people. And then we divide it again, and we have people doing more activity and people doing less activity, and looking at the effects of those interventions and their intersection with dietary manipulation, predominantly on skeletal muscle.
So, and you've been doing this for a long time, and arguably.
It's my 23rd year at McMaster, so yeah, it's been a while.
So you've got some experience. You've probably seen some things change. I want to check all the boxes here. I'm just going to ask some questions. These can be super simple answers. Number one, does protein damage our kidneys?
No.
Okay. What about our liver?
I don't want to just leave it at no. I can't leave it at no.
Okay,
but I mean,
okay,
I think the point is that's it's called the Brenner hypothesis. It was put out about 1970 or so. And in a lot of animal models, if you overfeed animals protein, the amount of urea that they generate then sort of taxes the kidney and causes glomerular failure, and essentially contributes to decline in kidney function. We've looked for that, and others have too, in randomized control trials where people are put on higher and lower protein diets. We just can't see any evidence of it. A lot of other people have got observational data, but there's nothing out there that makes me seem that it's so convincing. So yeah, that's the longer answer, but the short one is no.
Yeah, I just wanted to get that. And there's a paper, I think you authored or one of the co-authors on, I think it was a 2018 systematic meta analysis or review, and it said the same thing basically.
Exactly. So, yeah.
Okay, what about, does protein damage our liver? Because people think it causes liver damage now. Any evidence of that?
Yeah, that's. I always say that's an odd one. I think and I don't want to be trite about this. I think a lot of people sort of have a vague recollection of amino acid metabolism, and that the liver does play a very important role in that. And they sort of, it's like guilt by association. It's a large, brownish, pinkish internal organ. Maybe it's like the kidney. But it actually isn't responsible for any filtration. I mean, it's responsible for a lot of metabolic interconversion and obviously urea production, but nothing that I know of and have ever seen would associate protein with liver failure or liver damage or anything like that. Okay,
and then what about is it going to turn our bones into mush? Are we going to leach our bones of calcium because we have acid from the protein? Is that occurring?
Yeah. So that's a pretty old, another old hypothesis, acid ash hypothesis, and it's that protein causes an acidification of your blood, and then to balance that acidification, you get resorption of calcium from bone, predominantly to release phosphate to buffer the pH, and in doing so, you weaken your bone. The interesting part from my standpoint, and this has been a real, I think, sort of watershed change in people's understanding, is that when you look at calcium and vitamin D, and then actually the third bone supportive nutrient is protein. And I think it's a newsflash for a lot of people. I say, your bone is, for the most part, it's about 40% by composition protein. It's not just a stick of chalk. It's actually collagenous protein. Or, I mean, if it was a stick of chalk, it'd snap all the time, right? So, and that's been a bit of a revelation for a lot of people. But again, looking at causality and lots of meta-analyses, no evidence for an association between those two, for sure.
Okay, and the final kind of topic is we hear that protein causes us either to age prematurely or get cancer. What is the evidence on that?
Yeah, that's sort of I call that the new kid on the block because in 23 years or however long I've been doing this, the kidney one has been around since forever. The bone one too, and this is sort of the newer one, and it's the age-related activation of mTOR, which is one of these key signaling proteins that's implicated in aging and also implicated in cancer. The most compelling data from that actually comes from a lot of animal studies. And the difficulty I have in translating animal work over to human data is to understand what the protein requirements of all of the species that we're trying to look at and integrate are compared to us. So we have a lot of, pretty good knowledge about our protein requirements. But what's the protein requirement of a mouse? What's the protein requirement of, you name all the lower mammals that have been tested in this. And I just have difficulty. So there's lots of studies, we fed a mouse a diet containing 46% protein by energy. And I'm like, how does that translate into what real people eat and what real people do? And so I'm a little bit kind of dismayed there. The other angle on this is to then take a look at associative data. NHANES has been the one that's been used predominantly, and I don't think to date actually a very good analysis of the NHANES data has been done. And without spoiling the show, let's just say, and it's not in my hands, for a long time it was, and then I did my work and passed it on. We have an analysis of some NHANES data that's I hope going to see the light of day this year that actually counters the original NHANES data that's in the Walter Longo paper that's wildly cited as, protein causes premature aging and increases risk of cancer and lots of other things. And we don't see that association. All of the normal things, smoking's bad, inactivity's bad, but protein doesn't come out in any of the relationships, to be fair.
Yeah, and I had Don Layman on, and he talked about. I think you guys authored a letter to the journal, and they failed to publish it, talking about the criticism of that particular paper. But that's water under the bridge. Hopefully, the new data will sort of show us maybe more accurate data, perhaps.
We'll see.
I want to ask you. So, and maybe correct me if I'm wrong, but I think Don had something to do with showing that leucine was an important trigger in muscle protein synthesis via mTOR, perhaps. So my understanding is, you need a certain amount of leucine. Of course, you need other amino acids as well, but leucine seems to be this trigger. Maybe arginine or allergen has a second, maybe a little bit of a role. But it's quoted that 2.5 to 3 grams are needed in a bolus in a meal or something. And the part that confuses me about that is, my assumption is we're looking at the myocyte where this is happening, and you've got to get from the stomach into the blood and then eventually into the myocytes. Do we know what serum concentrations have to be? Do we know what myocyte concentrations of leucine have to be? So I can translate, because I'm thinking I'm a 6'5", 255-pound man, and I've got a 110-pound woman. I mean, even though our blood volume isn't completely double, but there's a significant difference. It's not a complete direct linear relationship, but there is a relationship. So how do we scale that for different sized people?
Yeah, look, Don wrote the book on this, and I've been really privileged to be on a lot of programs where Don has spoken, and I've spoken, or I've spoken, then Don's spoken. So I've listened to Don a lot, and I've learned a lot, and I always learn something new every time I talk to him. And he was the person who really triggered us on this sort of leucine concept. And our work fits hand in glove with a lot of the work that, Lane Norton did it when he was a grad student with Don. And so this per meal leucine dose is really how muscle protein synthesis works. So, to your point, Shauna, exactly. Leucine is the amino acid. It's sort of like it flicks the light switch on and everything then continues to go. You need all of the other essential amino acids, but leucine kind of starts the process. The per meal dose is, I think at best, it would be, sort of Don's off the cuff estimate based on trying to piece some data together from a number of different studies. But to your point, I would love to be able to give you an answer normalized for per kilo body weight. The closest I can come is to say that most of the work that we've done when we look at protein stimulating muscle protein synthesis, it requires a meal of probably at least 0.4 grams of protein per kilogram, up to maybe as high as 0.6, depending on age. It may be sex dependent, although we don't have that data. And then you can back calculate to that is somewhere between about 2.5 to maybe 3.5 grams of leucine per meal. But it probably scales, as you say, up and down. And, bigger guys need more. Smaller folks need less. As you age, it does appear you need more. If you're less active, you need more. And a lot of other factors in there. We're actually trying to pull together a lot of data that we've had for a lot of years now, and retrospectively look at what the blood concentration would be, to your question, but we don't know what that is yet.
Yeah, because that brings up a second interesting point, because my understanding is much of the work around protein and, muscle protein synthesis involve things like whey protein or other isolates where, it's cheaper to get, it's easier to get to human volunteers. And I eat, like I had 2 pounds of steak for breakfast. Now, my assumption is, and I think the physiology supports this is going to be slowly absorbed over time. I'm going to have a slow, steady, blood acidemia or aminoacidemia in my blood. Maybe I'm hitting that leucine trigger throughout the day over a period of, however long that's appearing in my blood, 6 to 8 hours perhaps. And so I wonder, because I asked Don, I said, he goes, we never really study anybody that eats 150 grams of protein in one shot. So is there any effort or concern to do that? Or is that just because there's not enough people to do that's even relevant? I wonder. I'm just kind of wondering about that, as far as, should I be eating 3 ounces of steak every 4 hours, or can I just eat a big whole steak at one time?
Yeah, great question. I mean, I think you're right, is that, and I would put my hands up and say that, we're guilty of that, is that we fed isolated protein sources. Most of them have been derived from milk protein, so wheys and caseins. We've done soys. We have done comparisons with beef. We have done sort of beef dose responses. And I can say that unequivocally, when you go head to head for the same amount of protein in, say, beef versus soy, for example, then beef does a better job. But it's absorbed much slower. It's not like a fast protein. It's a much slower digestion curve. And the profiles are different. We needed a new method to be able to account for those fluctuations, which in the short-term studies we used to do were really difficult. And so now we're moving to a method that actually integrates a lot of this over days. And so we're looking at sort of habitual dietary patterns and more of the real foods that people eat. And hopefully in the next couple of years, we'll be able to, give you some answers on that. I think the long and short is, though, that the dose responses for say the amount of meat that you're eating, for example, would probably indicate that instead of these discrete feeding periods like we've talked about in the past, it's more of a sort of a prolonged period that lasts, probably the whole day, I would say, until you go to bed and don't eat for a couple of hours. So that changes the scenario, and we'll have to do some better experiments and some better studies to figure that out for sure.
Yeah, and I think that we can get an indication of that with glucose. We see the protein or the glucose response to a protein fat meal. It's much delayed and much prolonged. So I think I wouldn't be surprised if the amino acids are doing the same thing. Would just make obvious sense to me. So I interviewed, perhaps Stefan von Vliet out of Duke University, and so he did a recent study on looking at eggs, whole eggs versus isonitrogenous amounts of egg white. And the effect of muscle protein synthesis was, more muscle protein, for instance, when you include the yolk. Now, the question is, I asked him, I said, hey, is it just a calorie effect? Because as you stated out before, you need a caloric excess. What are your thoughts on these whole foods? And I know you've mentioned that fats may have a role in muscle protein synthesis. We haven't really figured that stuff out. Are we getting anywhere closer with that and saying, hey, it's not just about protein? Because I know we're going to talk about physical activity being a huge slice of this pie, but what are we talking about with these other macronutrients or micronutrients perhaps being important, carbohydrates, fats, minerals, vitamins? What are your thoughts around that stuff?
Yeah, so Stefan's study was, I actually wrote an editorial for that because it was some pretty ingenious tech to show that effect. The interesting part to me, I don't think it's a purely calorie effect. The main reason I say that is because it was more calories, obviously, in the whole egg versus, say, the egg white. But the calories that were added were mostly fat. And I mean, it wasn't a carbohydrate effect. So I think it was probably due to something protein related that's in the matrix of the protein, and whether that's the structure and the digestion rate or the other nutrients that you're talking about, I'm not really sure. But one thing that we're I think getting more certain about is that food isn't just the sum of the individual parts, is that the matrix makes a difference, the nutrient density of the protein makes a difference, and that's going to affect some things that we probably don't have a good handle on right now. The lipid could be part of it, and we're going to have to do some better studies looking at whole foods and comparing those things, as opposed to an isolated protein source. But that study was a real eye-opener, I think, for a lot of people, and spoke a little bit to, it's the whole food that really is the key rather than the individual protein itself. So protein is a macronutrient. Yeah, that's important. We know that. But there's something else in the matrix of real food that's having an effect. And we're just not 100% clear on exactly what that is right now.
Yeah, and correct me if I'm wrong, I think there's an analogous study with dairy as well, showing perhaps whole fat dairy has a better effect on the same sort of things as does, isolated, whey or casein.
Yeah, it's an interesting, it's an older study now, and we still haven't figured that one out, but full fat milk did a better job than skimmed milk, isocaloric, or even if you added it up and gave you, more protein as skimmed milk, the full fat milk did a better job. So again, maybe lipid is part of it, or there's something to the matrix in full fat milk that's doing something we don't quite understand.
Yeah, let's talk, because we do know something about, carbohydrate. And I've talked to you about this, of what, how much insulin do you need? Is this permissive versus, do you need to expand it more? What role does carbohydrate play in muscle building? Is there any role in muscle protein synthesis, or is it more performance based? What's going on with carbohydrates?
Yeah, so I can say with good certainty that if you max out the dose of protein needed to fully and optimally stimulate muscle protein synthesis, you don't need carbohydrate to push it any further. When you do that and you keep adding carbohydrate, you get a greater insulin response, but you get no greater stimulation of muscle protein synthesis. So I think in that situation, the carbohydrate is just adding energy, nothing more, and giving you a bigger insulin response. So I think, most of the data would say that insulin is in a small range stimulatory, but it only requires going up from, like, if resting is 5 IUs to, say, 10, maybe 15 at most, which you're going to get from even a protein dose. You don't need carbohydrate for that. And so I think it's pretty much, it's a substrate. If you're concerned about, muscle glycogen, for example, then you're going to need that. And I would probably say that, most high-end sports, you're going to tap into that for sure. But it's certainly not needed to stimulate muscle protein synthesis. On a grand scheme and looking at all of the energy balance issues, if people are talking about, how much energy do I need, then if some of it came from carbohydrates, so be it. If some of it didn't, that's your call. I think it's preference, but it's certainly not needed, or it doesn't need to be elevated for protein synthesis to take place. That's a protein-driven and insulin, I think, permissive process rather than insulin-stimulating protein synthesis.
Let me talk a little bit about gluconeogenesis, because there's a concern or a fear that eating protein will inordinately drive people's blood sugar up. Steak turns into cake. And I mean, I've seen, some of the theoretical data, and, there's ketogenic and gluconeogenic amino acids. I think leucine is one of the ketogenic ones. I think there's 2 or 3 that are strictly ketogenic. Many can do both, and the rest are all gluconeogenic. But, I've seen, I think, estimates of maybe 54% of, amino acids could be potentially theoretically turned into glucose. But then I've seen radioisotope tracer data showing that a very small percentage actually does. And so I'm just wondering, because I think maybe there's something going on between people that are diabetics versus non-diabetics, and maybe there's a difference there. Can you speak at all to the gluconeogenic potential, and does protein turn into chocolate cake on us?
Well, so the answer is complicated, and I'll just start out by saying that. I think that there's a couple of considerations. So first, the question is really whether gluconeogenesis is a supply-driven process. So if you keep eating more and more protein and get more and more amino acids into your circulation, does your body just say, oh, well, we got to do something with these amino acids, so we'll make glucose? And I think that when you go back to the basic biochemistry of the hormonal response and everything, gluconeogenesis is highest when insulin is low and everything else is high. So when glucagon is up, when epinephrine is up, when, so the fasted state, if you like. So I think it would probably be fair to say that you can't store protein, so you got to do something with it. So definitely if you eat a lot of it, you're going to make urea, and then you got to do something with the carbon skeleton. And for the most part, you burn it, you oxidize it. A few of them become glucose if you need glucose. So I don't think that it's a supply-driven process. It's a demand-driven process. And although you can probably force it to be more supply-driven, maybe in a lot of, people who follow keto, for example, will say, well, when I eat a big protein meal, I get pushed into a less ketogenic state. I know personally that doesn't happen to me at all. I've messed around with keto and everything, and I don't find that at all in me. It just doesn't happen. But there may be people that are a little bit more sensitive to amino acids, and maybe you do begin to produce a little bit of glucose, but it's certainly, I've never been pushed out of a ketotic state by consuming a high protein meal, for example. I do think, though, if you're in a ketotic state, there's maybe a little bit of a demand for more blood glucose that you would begin to drive it, but it's not a demand-driven, a supply-driven process. So that when you eat more protein, you eat more amino acids. So as you say, steak becomes cake. That's a good one, actually. It's not that it's you get a massive surge of insulin after you've consumed protein. So you probably, in people with diabetes, again, things begin to get a really, you can get some odd situations that you wouldn't get in normal non-diabetic persons. But from my perspective, there's a little bit of biochemistry, and to your point about which amino acids can be turned into acetyl units. So all the branch chains form acetyl-CoA, and they look like lipid when they're metabolized a little bit. But the other amino acids, yes, they can become glucose. But the question is whether they do become glucose. And I would say that's driven more by a demand for glucose. So long as your blood glucose is in a normal range, you're not going to turn amino acids into into glucose unnecessarily.
There's been, again, I'll say there's been some associative data looking at branch chain amino acidemia. That is to say you've got too much branch chain amino acid, and that's been associated with things like insulin resistance and diabetes. And the people that sort of, I guess, have this particular belief is that, because you're eating more branch chain amino acids, i.e. mostly animal products, you're going to have branch chain amino acidemia, and that's going to lead to insulin resistance. Now, I've heard people say maybe that's reverse causation. What are your thoughts around, is it bad to have branch chain amino acids?
Yeah, so it's going back a few years now. I was at the NIH when we were allowed to get together in person. Seems like a lifetime ago now. And sat around with a lot of people, and we talked about whether the branch chains were causative in insulin resistance, and a couple of people who were more metabolomics and I would say animal-based scientists were pretty convinced that was the case. And then on the other side, and I was talking about protein and muscle, so it wasn't really me, but some other people who were more on the human side of the data believed that it wasn't actually a causative role, that it was indicative of insulin resistance, that you had elevated branch chain aminoacidemia. So it was, as you pointed out, sort of a reverse causality. My take on it now is that you can, in a lot of model systems, induce an insulin resistant state by, piling on the branch chains. As I said, they're metabolized in a similar manner to lipids. I mean, they look a lot like lipids in terms of their metabolism. So it's probably unsurprising that they're somehow connected to carnitines and the buildup of lots of other things that we associate with insulin resistance. Whether that happens in real people, I'm unsure. And whether you can pull out that effect from inactivity and then consumption of a lot of other things. So the original Newgard model, Chris Newgard, a guy down at Duke, when he was looking at this, would say that protein that's rich in branch chain amino acids against a background of a high fat, high maybe processed food type diet would cause insulin resistance. And that I don't doubt. But what specifically is causing it in that situation is that's a lot of people are trying to figure that out. But there is a certainty around that if the branch chains are up and they're persistently elevated, it's a decent predictor that somebody's edging towards insulin resistance, unless again they're eating a lot of protein and they're physically active, which is the one part that I rail on constantly. To your point about the role of physical activity, is that you can undo a lot of this by just making yourself more active. So I don't know yet whether I could say with confidence it's not. My feeling right now is that it's an indicator of insulin resistance rather than being causative.
Yeah, I talked to Ben Bickman, who's he's a metabolism researcher, and he basically thought, it's probably indicates that you're probably breaking down some of your own, muscle stores or your protein stores, and that's where but either way, it makes sense. It sounds like there's a lot of confounding factors, probably like everything we study, which is interesting. Now, you've pointed out that protein, as long as you hit your threshold of protein, and it doesn't matter where the source is, some sources are arguably better than others. You say whey protein is an excellent source. You've got I've seen something like potato and mushroom now being considered reasonably good sources of protein. But, we tend to see when we look at PDCAS and the diet stuff, we seem to see, milk and beef and animal products and eggs, and then we start to see soy and some of the other lesser healthful products. But what you would say is, as long as you get enough and you hit your bases, it's fine where it comes from. Is that fair to say?
Yeah, no, there's plenty of examples where, we've compared, animal to plant-based proteins, or we've done work with exclusively plant-based as well. I mean, it would be naive of me to say that we'll spend the rest of my time as a scientist studying animal-based proteins. It just happened that they were the ones that first, said, well, we'll fund the work that you're going to do. And now it's being driven a lot more by plant-based protein producers. So you can find isolated plant proteins, like you had Stefan Van Vliet on there. He would say that you can get like wheat protein, for example. It has a lot of leucine, and potato protein has a decent amount of leucine. But that's the isolated protein. That's not the protein that's present if you eat wheat or if you eat potatoes. So we've done work with potato protein, if you factor it back and say, how many potatoes would you have to eat to get that amount of protein? It would be 5 or 10 kilos of potatoes. So, it's a small part of the protein that's there, but once you've got up to a certain level, and where that is, I'm not 100% sure, but I like to say about 1.6 or as high as 2.2 grams per kilo. You just can't use the protein after that. You can't, there's no extra way of sort of storing it or putting it away like you can with glycogen or fat. You have to use it in the moment, but I don't think your body certainly can't tell where it came from, but you have to eat either more plant protein to get that level, or you have to eat the isolated sources of the plant proteins. So it's, one or the other. You can get it from plants, but you just got to eat more plants. And I think Don was the person who he has a great diagram that I've stolen off of him a number of times, but he says, here's a 3-ounce piece of steak. Here's the equivalent serving in, black beans, and here's the equivalent serving in tablespoons of peanut butter to get the same amount of protein. And it's, sort of 2 times and then 5 times the amount of energy that you would have to consume to get it from other sources. So, that's the trade-off.
Yeah, that's that's quite interesting to see how that plays out. What about so let's switch over into physical activity, because I think and I know you constantly talk about this. We hear the people that say you can't outrun a bad diet, but I mean, I am a huge proponent of exercise, and particularly resistance training. When it comes to muscle building, I think having muscle is important. I think it's incredibly important, no matter who you are, what sex you are, how old you are. Protein obviously is part of the equation, but how much, when it comes to building, maintaining muscle, just physical activity, put it in perspective. Is it 50-50? Is it a little bit? Where do we put physical activity in there?
Yeah, I mean, I borrow a phrase from Jack LaLanne. Exercise is king and nutrition is queen, and together they're a kingdom, right? I mean, and it's a trite phrase, but it's beautiful. Jack was doing it a long time before anybody, before the internet, and he definitely lived it. But I think that 90% of the struggle that's out there is the exercise side of things. I think nutrition kind of tweaks things, but the other phrase I use is that muscles are made in the gym, but fat is lost in the kitchen. So I think when we talk about can you outrun a bad diet? The answer is really, if we're focusing solely on weight loss, then the answer is outrunning is difficult, because it's really difficult. You can out-eat a good amount of exercise like that, no problem. People overestimate. You sweat an hour on the bike and then you eat a donut and it's done. I mean, you're in calorie balance, right? But at the same time, if we focus on the health benefits of exercise, then I think it's abundantly clear that being physically active and exercising is, that's really the key. So I'm often fond of saying you can't out-eat or out-diet inactivity, which is the sort of the flip side of the argument. And you can do a lot for your health by eating healthfully. But I think you can undo it by being physically inactive. And we're beginning to get answers around, even if you went out and said, you did your 30 minutes a day of walking, but then sat for the rest of the day and were inactive, that's not a good way to live. So, it speaks to why I'm probably, and many others, I think I can see somebody walking on a treadmill here, why people are doing that instead of sitting down, right? And not to guilt everybody else who's sitting down, that's fine. There's probably a point beyond which it becomes very difficult, the more seated and sedentary time you have, to out-diet or out-nutrition that to make yourself healthy. It really starts with physical activity, and then nutrition comes together, the two of them together. And then when you pull in the social part of it, then you're good to go, right?
Yeah, and just a point, I'm standing for this interview for you guys.
Me too. No, I since this, godforsaken pandemic, I spend way too much time sitting down.
Yeah, you got to get it in where you can. Hey, let's talk about it. So I've seen some of the work. I think maybe it's Brad Schoenfield and some of the other guys on the muscle building sort of side. They're showing that maybe you don't have to lift the super heavy giant weights to build muscle. You can build it with lower percentage. I've seen quoted like 40% on 1 rep max. What's the latest on what do I got to do in the gym now that I'm in the gym and I want to put on muscle? What do we know about, what works and what doesn't?
Yeah. So, credit to Brad. He's a machine with grinding out that data and really gratifying from my perspective, since we were a group that sort of, we didn't start it. It's an old concept, is that, that it used to be is that heavy weights were, sufficient, and necessary to grow muscle. And we sort of thought, we don't think that's true. We think you can get lighter weights so long as you go to the point of fatigue or a high degree of effort, call it whatever you want. And so we did a bunch of studies and showed that indeed, that was the case. And then Brad, who, and he admits this, was skeptical at the time, did his own study, and actually, to his surprise, I think, found that lighter weights, so long as you lifted to the point of fatigue, were able to do that. I think there's probably a limit. You can't curl your cell phone 300 times and expect to grow your muscle, but probably at about 30 to 40% of your 1RM, as you said, perform to fatigue, you can get muscle growth. Now, I'll say this though, is that it sounds as if it goes, oh well, that should be easy to do, but it hurts. Lighter weights lifted to fatigue are not fun. Not that heavy weights are a ton of fun either, but I mean, fatigue is fatigue, and how you get there really doesn't appear to matter. So you can do it with lighter weights, not the lightest weights, or you can do it with heavy weights. So that for me, the older I get, has been a little bit liberating, because it means I don't have to get under the bar and crush myself every day. I can just do a lighter workout, and hopefully, my event horizons is a long way off now. So to stay as active as I can and still be able to move around a little bit of iron for sure. But I think that it's probably as low as 30 to 40%, but you just have to use a good degree of effort.
Do you know if, this kind of following up on this, because, there's a certain different level of arousal level for lifting a big heavy weight than like if I'm going to go and deadlift 500 pounds, I've got to switch on mentally. There's, I presume there's some neurological things and perhaps some hormonal things that are going on that are not occurring when I go to deadlift 225 for 50 reps or something like that. But do we know, does that also change the frequency with regard to recovery? I mean, because recovering from a big heavy deadlift workout may take longer than I would imagine. So can you talk about timing a little bit? Does that change the timing? And what is the timing? People say twice a week, once a week. There's debate about that. What do you think? Do we know about timing?
Yeah, that's a good question, and I don't know that I have a great answer, to be really honest with you. What I will say is that we've got a couple of studies now where we've had guys lift lighter weights, and their self-reported enjoyment is not as high as guys who lift heavier weights. So it's not as much fun, like I said. I do think that you don't get as much connective tissue wear and tear with the lighter weight that you do with the heavier weight. And to your point, you can't just stroll up to the bar and try and yank up 500 pounds. No way. You got to get ready for it. Smelling salts, the pre-workout, you're going to get fired up. You got to get everything locked and loaded, ready to go. So it is a different way of lifting. I do think that there's some merit in mixing in the lighter stuff, only because you could come back and do it again maybe 2 days later, or maybe even a day later. I've had a lot of people tell me that they've, during the pandemic, have switched to using bands. So not as heavy of an eccentric or a lengthening load. And they find that that's a lot easier. They can come back and they can do it day after day after day. So, is it no pain, no gain, or is it no pain, no pain? I'm not really sure I have a great answer, but I would think that you could probably train more frequently with lighter weights than you could with heavier. But, I'm never one to say it's got to be lighter weights all the time. Don't ever do anything heavy. That's not really the way I think people should train, but maybe you don't have to go heavy all the time.
Yeah, and that's fair enough. And that's kind of what I think. I think they all work, and you should do them all, basically, is my take on that. And that's how I tend to do that. Let's talk a little bit back about, there's lifting, and then we talk about, nutrition timing around that. So is there any compelling data that says you need to get that protein in within 30 minutes of leaving the gym, or what's the latest research on that show, and how much effect does that have?
Yeah. So I think when you go way back to the beginning at the nutrient timing sort of, I guess the original studies where they looked at this, it was a combination of two things. First, they were looking at not only at stimulating muscle protein synthesis, but also replenishing glycogen. So I think the two sort of got tied in together. And it does appear that for glycogen replenishment, maybe the sooner the better that you get carbohydrates on board. But for muscle protein synthesis, we've got data. I mean, it's pretty old data now to show that if the workout that you do is pretty strenuous and you work pretty hard, that window is open for a long time, maybe even as long as 2 days. So every time that you eat in that window of opportunity, if you want to call it that, even up to 2 days later, is going to stimulate protein synthesis to a greater degree than you would have if you hadn't lifted at all. So it may be that, maybe it is sort of, 6 to 8, maybe 10, 12 hours. But some people like to say it's not a window, it's a barn door, and it's open for a long time. And so long as you're consuming protein in there, you're good to go. So I don't think that the walking around the gym with the protein shake is really necessary. If that's your thing, man, that's all good. But it's definitely not necessary.
So talk to me about, there's a study you were one of the authors on. It looked at testosterone levels or hormone levels in general, young, healthy, resistance trained males. And you found that there really wasn't a relationship between testosterone level and muscle protein synthesis. It was dependent upon really the hormones or the receptor side of things. So what's the story on that?
Yeah, so the long and the short, for a long time, there was a lot of, observations where people drew bloods after somebody had lifted. And they noticed they had this spike in testosterone, and growth hormone did the same sort of thing. And, so the attractiveness of that hypothesis, knowing that, men have got usually 10 times more testosterone than women. And, so is that the testosterone and growth hormone got thrown in there as well, was driving the anabolic response. And so this is the sort of what we call the acute rise in testosterone and all of these anabolic hormones, insulin-like growth factors in there too. And, to us, the main sort of point around that kind of stuck out was, first, it's really short. Like, it doesn't last more than 15 or maybe 30 minutes tops. And it's really actually pretty small. Most men have that sort of a diurnal fluctuation in testosterone. And the change was always within the range of what was sort of a normal daily fluctuation in testosterone. At the same time, we know women can hypertrophy, and they don't have testosterone. So everybody said, "Oh, well, growth hormone takes over." We can talk about that another day. But the main point is, we said, well, it's not really compelling to say that this acute rise is responsible for muscle protein synthesis. So we did a bunch of studies to sort of check that out, and we haven't been able yet, and I'd say we've probably done about 6 studies to date, find a relationship between the two. So the guy who was the biggest sort of responder in terms of his testosterone wasn't the person who gained the most muscle or anything else like that. But when we took the muscle biopsy and we looked at the amount of androgen receptor that they had in their muscles, so this is what the testosterone binds to, that was a much better predictor of what somebody would gain. And so there's probably a lot of, like, we just look for the receptor, there's probably lots of other things. And I think that, to me, the most compelling observation is that women, from a relative perspective, gain about as much muscle as men. Now, men are here and women are here, but they tend to go up and down in a coordinate fashion. So I don't think it's a testosterone driven process. Now, when you take steroids and you elevate testosterone up here and it's there all the time, for sure, it works. But we're talking about fluctuations within normal diurnal variation as opposed to 2 standard deviations greater than normal, which is what steroids do.
Yeah, and because that's what people would say. What about the guys on Mr. Olympia? Well, obviously they're super physiologic levels of everything, and it's more than just steroids. They're kind of a human chemistry experiment.
Lots of stuff going on in those guys for sure.
Yeah, exactly. Hey, there's a gene called the myostatin gene, which I'm sure you're familiar with, and there've been talk about modifying athletes with these myostatin genes, and there's some animals that have that. There's some cows. I think one's called the Piedmontese animal, and there's some other ones similar, and they grow these enormous muscles. I know, but what I've found out, what I've heard subsequently, is they're not very strong. Even though they develop all this muscle, they don't develop any strength. So is there any sort of promise or myostatin inhibitors? Is that going to go anywhere? Or is there anybody that's going to look at that?
Yeah, great question. A lot of excitement around myostatin when it was first discovered. A lot of potential drug therapies where people have tried to. So myostatin is like pulling the brakes. It puts the brakes on anabolism, and so if you can antagonize myostatin, then it's like you take the brakes off. The animals that you talk about are generally they're freakishly large, but the meat that they produce, if it's a cattle, like there's a double muscle Belgian cattle or something, is not of the best quality. So to your point, is that it's not exactly like they're twice as strong, or they don't have strength proportional to their muscle mass. So it speaks to the quality of the tissue that you generate as a result. I think that's probably going to be true of a lot of these, what are called SARMs, selective androgen receptor modulators. So these are the compounds that basically go to the androgen receptor only at the muscle, is that they generate muscle, but it might not be the muscle that's of the highest quality. And again, it seems so trite to say, is that the muscle that you're going to add is the greatest quality, and it's going to make you stronger, comes from the gym. Passively building muscle appears to almost build, I'll just call it for the sake of argument, low quality muscle, if that's the right way to say things.
Yeah, I've had some of that meat, and actually it's interesting. It doesn't have much connective tissue, and so it's very tender, and actually tastes. It's actually is a pretty good dining experience, but it's missing some of the connective tissue. And as we know, muscle is not just actin and myosin filaments. There's a lot of collagen within muscle itself, and so you've got some other things going on. What outside of lifting weights and eating protein, what are the other things that are out there that will help promote muscle building? Are there other things we can look at lifestyle that I have control over?
Yeah, I mean, I think it would be wrong if I were to leave you and say nothing about creatine, for example. I mean, it stood the test of time as a supplement. It works. Generally, people either respond fairly well to it, and you can tell if you're a responder. You take some for a few days, and if you employ the loading dose, you'll notice that your weight will go up. It's probably mostly water retention, obviously, in that shorter period of time, but it does go into your muscle, and it does help, gain a little bit more muscle. We've got some data, and others have shown this too, that higher dose omega-3 fatty acids can make your muscle more anabolically sensitive. It appears to work really well in older people and in women in particular. I can't say why. It was really effective in our hands at mitigating atrophy. So we put these were younger women, in a knee brace to cause atrophy in one of their legs. But if they'd taken high dose omega-3s, they were actually protected against the atrophy. So an interesting, maybe if you're going in for surgery or something, like that. And again, from a protein perspective, the higher the leucine, the better things would generally tend to be, because that's going to fire up the protein synthetic machinery. Outside of that, there's probably a few other supplements that might be important in there. There's probably some minerals that we're maybe underappreciating that need to be in line. Magnesium is one that people have talked about. Definitely calcium, and it appears that vitamin D is playing a role in there. I think the vitamin D is really, make sure that you're at a sufficient level. I don't think beyond sufficient it does much, but if you're in a northern latitude like I am, for example, than the useful sunshine that we get in a year. And plus, you don't want to be out in the sunshine. That's going to give you skin cancer, right? Is that people just don't spend time in sunshine anymore, or they put on sunblock to reduce their skin cancer risk. And then as a result, vitamin D levels are ridiculously low because the fortification in foods is just not sufficient. So I take omega-3 and I take vitamin D, and that's pretty much it. And I will mess around with creatine, mainly when my sons bring some home. I steal some of theirs. So.
Yeah, I personally, I get a lot of creatine in my diet, eating, 4 pounds of beef a day, but so I don't tend to worry about that. So, I mean, interestingly, that concept of the omega-3s, and somebody's asking, what do you consider a high dose omega-3? But I think it's, people going in for surgery, for extremity surgery, going into a cast, that may be something to consider supplementing. Kind of interesting. So what do you consider, what is a dosage of vitamin or of omega-3 for you?
Yeah, so the dose that I'm taking now is about 1.5 grams per day, and it's split almost evenly into EPA and DHA. So those are the two long chains that are really important. I think you have to be a little bit of a conscientious consumer about where you get that from. There are some companies that just sort of ship it out, and a lot of it is in the oxidized state, which is not the best state for it to be in. Obviously, it's not useful in your body in that fashion. And so you get what you pay for in that scenario, is that the higher quality stuff that's out there and that guarantees that the oxidation status is good is the one that you want to aim for. But I think at least 1.5 grams per day is what I try and aim for. In the studies we did, we were a little bit over 2 grams, but again, it accumulates over time, and so it's not necessary that you get a really high dose, just that you consistently take it.
Yeah, one more quick one, Stu. Somebody's asking about nitric oxide, and does it have a role in performance or muscle building, perhaps?
Yeah, it's more of a recent sort of kid on the block. I think if you'd asked me 10 years ago, and you just said, beet juice is going to be the next big thing in enhancing performance, I'd have laughed. 5 years ago, I'd have said, oh yeah, I've seen a few studies with beet juice. And interestingly enough, it's not that beet juice has the monopoly on as a source of nitrate. In fact, if you grow beets in nitrate poor soil, it's not a great source of nitric oxide as a precursor. So, and again, people used to say, well, nitrates are bad, but nitrate in this situation is actually converted to nitrite by the bacterial population that you have in your mouth. So again, the subtlety and the devil that's in the details. If you use mouthwash, good oral hygiene practice, but not so good because it kills the bacteria that converts the nitrate to nitrite. Which is the step that's needed to make the nitric oxide. But things like spinach is a decent source of nitrates, and I mean, just about any root vegetable that's grown in nitrate-rich soil can give you these nitrates, and it has been shown in a few populations to be very effective. It tends to be less effective the higher the fitness of the athlete, and it's predominantly endurance type events that I've seen the data for it. I don't follow that literature as much. I absorb it from, last year I was going to say I didn't go to any meetings, so it didn't matter, but mainly going to meetings and listening to other people. But there's something there, I think, and definitely from a long-term health perspective, I think we're beginning now to sort of say is that maybe some of the effects of higher vegetables and lowering blood pressure aren't the potassium sodium mechanism that we thought, but was probably mediated by the nitrate content of the vegetables.
All right. Some of the people are saying they're just going to eat bacon. So,
well, so that's an interesting question, isn't it? Because as soon as you hear nitrates, and we were told that they were bad, I'm like, well, can the nitrates come from cured meats? And that's never really, to my satisfaction at least, been addressed in the answer to the question. But maybe it's sort of a little bit of confirmation bias to say, well, I've got beet juice and maybe bacon juice is not the right thing, but Yeah, I don't have a problem with eating bacon at all.
Yeah, well, that's so I'll tell you, if you need research subjects to do a study on meat, I guarantee I can get you hundreds of them. So if that ever comes up, let me know.
Awesome.
What do you guys? What's new on the horizon? What's new on the horizon for you? And then where can people find more of your stuff at, Stu?
Yeah, 23 years. I'd say the first sort of half of my career, we spent a lot of time looking at muscle in younger people. We're really interested in how to maximize muscle growth. And it's been an evolution, as you said, to sort of realize that it's not just about being fit as you get older, but it's about being strong. And so from the latter half of the time that I've been a McMaster, it's really been focusing on muscle and its role in aging well. And so most of the stuff that we're working on going into probably the next 5 years is focused on not necessarily, people say, really old people, but people who are aging and trying to age successfully, whatever that means. But I clearly think that being physically strong allows you to be mobile, and mobility is a huge predictor of morbidity and mortality. And that probably in combination, obviously, with eating well, and having a good level of fitness, having a great social circle, are all the things that come together to make an older person a successful ager. And then that's been really where we're going to push things in I would say the next 5 to 10 years for sure.
Yeah, it's kind of funny as we personally get older, we get more interested in aging.
Yeah. Well, somebody said to me, it's as you get older, the research becomes me search, right? So I'm looking for answers as how to age well myself. So for sure.
Anyway, well, Stu, where do we get you? Where do we find you on social media or other ways?
I'm on Twitter. I'm MacKinProf, MacKinProf. Same handle on Instagram. Or I'm SMP PhD on Facebook, and I'm on LinkedIn as well. If you do a search, you can find me.
All right, Stu, thanks so much for doing this, and continue the wonderful work you do. And like I said, we got to get the protein is not bad message out there. Continue to do that, and exercise is essential. So thanks
Absolutely.
again. And I know our people are saying, can you come back? And I said, well, maybe if we get some new research down the road, we can have you back on if that's okay with you, Stu.
Yeah, absolutely. Be happy to come back on, Sean. Thanks for having me.
Sure.
It was a pleasure.
And this is very helpful. I'm sure a lot of people will benefit from this. Okay, have a great one. And the rest of you guys, we'll see you tomorrow. Bye-bye, everybody. Take care now.
See you guys. Take care.